2.2 Tomato Plants Histogram. A histogram can be used to represent the distribution of numerical data. Number 1. The data represent the number of days it takes for different tomato plants to produce tomatoes. Use the information to complete the frequency table. So one thing you should know about frequency tables that I would never express the frequency table this way. I think it's confusing, and I don't really believe that anyone actually uses frequency tables this way. You'll notice is sort of weird about this. You see, you have a category 40 to 50, then 50 to 60. So a logical question you might have is, well, where should 50 belong? Should 50 belong in this category, or should 50 belong in this category? And frankly, there's no, rhyme or reason why it should be one way or the other. I'm going to tell you what is normally the case. So the domain of this frequency should be if a number is greater than or equal to 40 and less than 50. So technically, I guess like 49.9 would be included. Since we're really talking about only whole number days here, just for my own benefit, I like to cross out this last number and write the number right before it. Because I think it's just strange to see the same number appear twice. I don't think it's too much understanding is going to be going on if we do that. All right, so if that's helpful to you, do it. I have never seen a frequency table where they show the same number twice. I don't know why they do that here, but that's certainly not how I would do it. So what I'm going to do now is I'm just going to go through and I'm going to cross off numbers as I go through them, and count out what their frequency is using tally marks. So we got 47 here first, so 47 would belong in this category. 52, this category. 53, this category, right? 55 here, 57. And what's actually kind of nice about this, you'll notice, is that they actually wrote all these numbers in numeric order. So it's actually going to be very easy to keep track. I know once I get past 59, I'm hopping over to the next category. So what now I'm going to do, just to speed up the process a little bit, is just tick off any number between 60 and 69. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 2, 3, 4, 5, 7, 8, 9. All right, or I could have just written 9. This is equal to 1, equal to 4, equal to 9. Now I'm looking for numbers from 70 to 79. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm just going to write 9 here. 80 to 81, 89. 1, 2, 3, 4, 5, 6. And just one number for that frequency. Okay, so now they actually want us to plot this histogram. And they've already labeled it for us, which is nice, and already sort of given it a scale, although I would have preferred grid lines for graph paper. But you take what you can get. Okay, so it's actually kind of tricky because the first interval they give us is 30 to 40, and that's not included. So from 30 to 40, there's going to be nothing there. Now from 40 to 50, I have a frequency of 1. So I'm going to make sure this little bar of my histogram goes up to 1. All right. And one thing it's good to know about a histogram, the y-axis is always going to be frequency. Always. Then the interval will always be represented on the x-axis. All right, so now for 50 to 59, I'm going to go up to 4. Let me use a straight edge. I really don't care for this graph, but we're doing a rough sketch, I suppose. All right. And in a histogram, you like to have all the bars be the exact same color. You don't like to see the separation. They should be touching. Exactly right. If you look back to the do now, we can see that they're all the same color, all touching. I guess I could have left it white, but I'll just shade it in. All right, next category, from 60 to 70, or 60 to 69 really, we've got a frequency of 9. So I'm gonna extend this all the way up to 9 now. That looks about right, let's see. Yeah, it looks good. All right, you can see that this is the highest frequency of all the intervals. All right, then we get I'm sorry, that was a lie. It's the tied for the highest, because 70 to 80 also has a frequency of 9. All right, 80 to 89, frequency of 6. And then 90 to 99, frequency of 1. Great. All right, so that's how we graph a histogram. This is, you know, you should have done this last year in Mr. Frankwitz's class, or maybe even 7th grade, I'm not sure which one. So hopefully this is jogging your memory of how we graph a histogram. All right, so next what they want us to do is they want us to take the same histogram, and now they want us to create smaller intervals. So we used to have a width of 10. Now they want to use an interval with a width of 5. So that's gonna look, if I look up here, if my intervals, you can see this first one is 30 to 35, which really means I'm gonna end at 34. All right, so I have nothing here between 30 and 35. In fact, the only interval I'm going to start at is between 45 and 49. So that's going to be this one right here. And I see that I only have one. Actually, no, I'm going to write my intervals out because this is doing too much in my head. So I'm going to write out, make a little table. And I write frequency here. And then days over here. So my first interval, like I said, will be from 45 to 49. And I'm going to use the one I was talking about where I cut it off at the number right before. I don't like writing the same number twice. I don't think that's a good habit to get into. All right, so you can see really there should be 5 numbers in each one. Right, 60, 61, 62, 63, 64, that's 5 numbers total. It looks like it's 4, right? But if you count, include both the beginning and end, we really would consider that to be 5 numbers. All right, if I remember correctly, the last number was 90, so I'm gonna make sure that when I end this, I don't go beyond 90. I'm sorry, that should be 85 to 89. And 90 to 94. Okay, so now we can sort of look at both of these. I see I've got 47, so that's 1 there. Between 15 and 54, 1, 2. Between 55 and 59, 1, 2. Between 60 and 64, 1, 2, 3, 4. 65 and 69, 1, 2, 3, 4, 5. All right, 70 to 74, 1, 2, 3. 75 to 79, 1, 2, 3, 4, 5, 6. All right, 80 to 84, 1, 2, 3. 85 to 89, 1, 2, 3, and then lastly 90 would just be 1. So what you're looking at now, if we're going to compare these two, right, this is going to have a lot more bars than our original one. So the first interval is 45 to 49, and that's only going to be up to 1. right, this is just a sketch. It's not on graph paper, so it's not going to be super accurate. All right, 50 to 54 goes up to 2. 55 to 59 is also at 2. 60 to 64 goes up to 4. 65 to 69 goes up to 5. 70 to 74 is up to 3. 75 to 79 is 6. That's our highest frequency. 80 to 84 is up to 3. 85 to 89 is also at 3. Then 90 to 94 is at 1. Okay, so if we want to compare these two, fold this a little bit so it's easier to see. All right, over the same interval, we can see that the graphs do look a bit different. Okay, so look at those for a second, and then we're going to answer a few more questions. It often takes some playing around with the interval length to figure out which gives the best sense of the shape of distribution. So what might be a problem with using interval lengths that are too large? So what they're saying is, if I'm looking right here, up here on my top graph, I have larger interval lengths, right? They're wider. So why might it be problematic if I were to use a graph like this as opposed to a graph like that? What might I lose when I make a graph like this? Well, one thing you could say is that it's less specific, right? Between 50 and 60, right? What if all the numbers were like at 59? It wouldn't matter because I don't know exactly where the numbers lie between those two numbers. So large intervals are too specific. What might be a problem with using interval lengths that are too small? Well, this one actually is pretty good. But let's say I were to make it even smaller, if I were to go up by ones. Then I would have a very, very wide graph that doesn't go up very high. So that really wouldn't tell me very much about where most of the data is. So if they're too small, it's too specific. Doesn't help paint a big picture. Right, especially imagine if you were talking about like numbers that were in the millions and you decided to break it up by 1. Well, that graph would have that x-axis that went on forever, right? It wouldn't be very helpful. What other considerations might go into choosing the length of an interval? Yeah, well, I mean, think about like what the possible numbers could be. It depends on what are you measuring. Right, if we're measuring inches of rainfall, it would be very helpful to have very small intervals because it doesn't rain a ton in terms of inches. Like I said before, if you're talking about millions of dollars, then you're going to want very large intervals because you're talking about numbers that span a very large domain or range. So it's really going to depend on the things that you're measuring. All right, that's all for 2.2.